The South China Sea does not give up its secrets willingly. It offers surface, blue water, contested reefs, shipping lanes that carry a third of global maritime trade, and it offers the appearance of transparency that comes with any open ocean. What it does not offer is visibility beneath its surface or beneath the islands that ring its perimeter. That concealment is precisely what the planners in Beijing had been exploiting for 15 years when the intelligence community finally assembled a target folder, complete enough to support a decision. The folder described a facility on the southwestern coast of Hainan Island that had no public designation, no acknowledged existence in any official Chinese government document, and no surface signature that distinguished it from the coastal geography surrounding it. What it had beneath that geography was a hardened underground harbor capable of sheltering two Type 003 aircraft carriers simultaneously, protecting them from any conventional strike package that any adversary in the Western Pacific could assemble, and allowing them to sortie into the South China Sea through a submarine access channel that emerged 3 kilometers offshore beneath 40 meters of water. The facility was not a secret in the way that things are secret when nobody knows they exist. It was a secret in the way that things are secret when the people who know they exist cannot prove it to the standard required to act on the knowledge. The imagery that documented its construction was ambiguous. Coastal infrastructure projects of the scale visible from orbit could be civilian port development, naval expansion of a type that fell within acknowledged parameters, or exactly what the analysts assessing it believed it to be. The signals intelligence that characterized its internal communications infrastructure placed it on a command network whose architecture was consistent with a major fleet asset. The geological survey that mapped the subsurface excavation profile, conducted over 4 years using seismic sensing equipment disguised as oceanographic research instrumentation on vessels that operated within China's claimed territorial waters under legitimate research permits, established a chamber geometry and rock depth profile that was inconsistent with any civilian purpose and precisely consistent with what the analysts had argued it was since the first imagery flag 3 years before. When the human intelligence source that provided the facility's internal layout, the carrier berthing schedule, and the access channel navigational parameters was exfiltrated from Hainan in the early hours of a morning that will not be specified here, the target folder reached the threshold that converted intelligence into targeting. The decision that followed was made at a level of the command structure that does not appear in public accounts of military planning. In a conversation that lasted less than 40 minutes, and that will not be declassified within the professional lifetimes of anyone involved in it. The operational requirement was precise. The facility had to be rendered permanently inoperable, while both carriers were confirmed present in the underground harbor. Both carriers present simultaneously was a condition that the berthing schedule indicated would occur during a scheduled maintenance cycle that created a 72-hour window. The window was 11 days away when the decision was made. The mission package had 9 days to be assembled, briefed, and positioned. 9 days is not a long time to build a mission of this complexity. It is also not a short time for people who have been training for this category of problem for their entire careers and who had been building the conceptual architecture of exactly this package in classified wargaming exercises for 3 years. The package required 2 aircraft, a sequential weapons employment timeline with a 6-minute interval between releases, a support architecture of electronic warfare assets drawn from 3 services and 2 allied nations, and a fuzing solution that had to account for Hainan's coastal granite formation, the water table depth above the harbor ceiling, and the possibility that the access channel's hydrostatic pressure would affect overpressure transmission in ways that standard underground facility modeling did not address. An engineer spent 4 days running models on that last variable. He was not told what the target was. He was given the geological parameters and asked for a solution. He provided one. The two B-2 Spirits lifted off from Whiteman Air Force Base at 8:33 p.m. and 8:41 p.m. on a Tuesday evening that was, on the surface, indistinguishable from any other. The base's communication patterns and flight scheduling data, visible to the signals intelligence systems that monitored it, had been managed in the preceding days to establish a pattern the departure of two aircraft would not disrupt. The pattern management was not perfect. What it was sufficient. The signals that would have indicated something unusual were absent, and the signals that were present were consistent with routine activity. The assessment by the collection systems monitoring Whiteman was that nothing significant was occurring. The assessment was incorrect. The aircraft were already over Kansas. The flight to the South China Sea from Whiteman required 21 hours at the cruise parameters mandated by the mission profile. 21 hours placed the crew at the weapons release point at the outer boundary of sustained precision performance, not beyond it, but at it. The pilot had been awake for 26 hours by the time the release window opened. He had slept for 2 of those hours on the transit, a managed rest cycle in the right seat while the autopilot held altitude and the mission commander monitored systems. 2 hours of sleep at altitude in a B-2 cockpit is not restorative rest by any physiological standard. It is the difference between a pilot who cannot perform the release sequence at the required precision standard and one who can. He had been doing this long enough to know which side of that line he was on. The tanker contacts that sustained the mission over the Pacific occurred at intervals that the planning had optimized against the fuel burn curves and the available tanker orbits. The first at 1:14 a.m. over the Central Pacific, the second at 11:47 a.m. east of the Philippines, and the third at 5:33 p.m. as the aircraft transited the outer edge of the Philippine Sea. The third contact was the one that mattered most to the overall timeline. It placed the aircraft at their final fuel state for the penetration phase, eliminating any margin for the kind of extended holding that a delayed release window might require. The window was not going to be delayed. The intelligence feed that confirmed both carriers were in the underground harbor had been updated at 4 p.m., 90 minutes before the third refueling. And the update had confirmed their presence. The window was open. The package was going to fly it. The air defense architecture protecting Hainan Island was the most sophisticated that American planners had ever built a mission against. Not the most dense. Iran's integrated network covered more geographic area with more individual systems. Not the most technically advanced in any single component. The S-400 systems that Russia operated exceeded the capability of any individual Chinese battery. What made Hainan's defense architecture uniquely demanding was the integration, a unified command and control system that networked every sensor and every effector across the island's defense perimeter into a single operational picture with automated queuing that reduced human reaction time at every decision node to the minimum that physics allowed. The system had been designed over a decade of development specifically to address the threat category that the B-2 represented. The Chinese air defense engineering community had studied every publicly available piece of information about how American stealth platforms penetrated air defense networks, had assessed what the classified capabilities were likely to be based on observed effects in exercises and operations, and had built their response around closing the specific gaps that American doctrine exploited. They had done it well. The mission planners had studied what they had built with the same rigor and had built the EW package specifically to address what they had found. The EW package was provided by assets from two nations. The American component consisted of 3 EA-18G Growler flights operating from the carrier USS Carl Vinson, 500 miles east of Hainan. The Allied component, its national origin will not be specified, provided 2 additional electronic warfare platforms positioned to address the southern sector of Hainan's coverage. The coordination between the 2 national components had been rehearsed twice in exercises whose stated purpose was unrelated to what they were actually rehearsing. By mission execution, the 2 components operated as a single EW architecture, with shared situational awareness and a common timing protocol. A capability that had not existed between these 2 nations' EW communities before the exercise series began. The penetration corridor crossed into Hainan's airspace at 7:14 p.m. local time, still light, the sun 40 minutes above the horizon, the sky over the South China Sea carrying the orange and purple gradient of a tropical evening that made the thermal environment across which the B-2's infrared signature would need to disappear markedly more challenging than the night conditions that the mission had originally been planned for. The window had not shifted. The planning had accounted for the lighting conditions with a routing adjustment that kept the aircraft in the shadow band of a cloud formation that the weather officer had identified in the forecast 72 hours earlier, and that was, at mission time, exactly where the forecast had placed it. The shadow band was 11 miles wide. The penetration corridor ran through the center of it. The HQ-9B battery at the northern tip of the island detected the first anomaly at 7:19 p.m. Not a target track, not a weapons quality return, but a frequency anomaly in the electromagnetic environment that the battery's passive detection system flagged as inconsistent with the jamming signature it had been trained to expect from American Growler operations. The anomaly was different in character from the known American EW signature. It was different because part of the jamming architecture generating it was not American. The HQ-9B's passive system had an extensive library of known American electronic warfare signatures. It did not have a comparable library of signatures from the Allied nations' platforms. The anomaly it detected was real and it was significant, and the operator who observed it reported it accurately and promptly. The report traveled up the integrated command chain to the Regional Air Defense Controller in 8 seconds, a transmission time that reflected the network integration that the Chinese planners had spent a decade building. The regional controller looked at the anomaly report. He looked at the EW environment across his entire sector. The Growler jamming he could characterize, the Allied platform signature he could not, and the combination of both producing a coverage pattern that was suppressing his long-range surveillance radars across a sector that he had been briefed in the classified threat assessments he reviewed quarterly, was the most likely B-2 approach vector if an American strike was ever executed against Hainan. He had been told in those assessments what an American strike would look like in terms of EW signatures and timing. What he was looking at did not look like the briefed signature. It looked like something he had not been briefed on, in a sector he had been told to watch, at a time when his radars were being jammed. He issued an immediate sector alert at 7:21 p.m. and authorized all batteries to transition to active search mode. The transition to active search mode produced an electromagnetic environment that the B-2's passive warning receiver classified, logged, and displayed in the order of threat priority within 4 seconds of the first emissions reaching the aircraft's antenna array. The pilot counted the threat symbols. He noted the ones in weapons guidance mode, 3 of them, none yet in active tracking, and the ones in search mode, which was most of the display. He was 11 minutes from the initial point. The mission commander transmitted the contingency activation code on the Allied data link channel at 7:22 p.m. The Allied electronic warfare platforms received the code and transitioned from their pre-planned frequency coverage to a broadband suppression mode that had not been part of the primary jamming architecture. A reserve capability that generated enough electromagnetic noise across a wide enough frequency range to temporarily degrade the coherence of the integrated command network's data fusion. The degradation lasted 47 seconds. 47 seconds in which the batteries that had just been ordered into active search mode were generating returns that their fire control systems could not confidently correlate with each other because the network that was supposed to merge their data into a common picture was operating at degraded capacity. In those 47 seconds, one HQ-16 battery at the western edge of the approach corridor acquired a target track, not a confirmed track, an ambiguous return that the fire control system assessed at 31% probability of being a valid aerial contact rather than a jamming artifact. 31% is not a firing threshold. The battery commander knew that. He was also looking at a sector alert, a degraded network, anomalous EW signatures that his training had not characterized, and 41 years of professional preparation for exactly this scenario. He made the decision that his training and his judgment and the weight of what he understood was at stake produced. He authorized a 2-missile salvo against the ambiguous contact at 7:23 p.m. His fire control system registered the action and logged it as a non-doctrine engagement, a launch below the authorized probability threshold. He would answer for that notation later. The missiles were already climbing. The B-2's warning receiver showed the HQ-16 fire control radar transition from search to track at 7:23 p.m. and 14 seconds, and showed the missile uplink signatures go active 2 seconds later. The mission commander ran the geometry and the time it took to exhale. The HQ-16's track solution was imprecise. The degraded network had prevented the battery from receiving the correlation data that would have cleaned up the ambiguous return into a weapons-quality track. The missiles were flying on an imprecise solution. Imprecise at HQ-16 engagement ranges meant a missed distance that could be anywhere from safe to fatal, distributed across a probability function that he could not resolve from the information available. He transmitted the suppression request to the Growler flight on the nearest active frequency. The lead Growler's EW officer received the request, assessed his available power allocation, and jammed the HQ-16's uplink frequency at maximum output within 3 seconds. The uplink degraded. The missiles flew on their last computed solution, a ballistic arc that carried them through the airspace that the B-2 had occupied when the track solution was generated, not the airspace the aircraft currently occupied. Both warheads detonated against empty atmosphere at 7:24 p.m. and 9 seconds. The proximity fuse explosions were visible from the Hainan coastline. 2 sharp flashes in the evening sky over the water, separated by less than a second. The regional controller saw the detonation reports and understood that his battery had engaged a target. He did not know yet whether the engagement had been effective. The ambiguous return his network had been tracking had disappeared from his picture at the moment the jamming intensified, and a disappeared return in a heavily jammed environment told him nothing certain about whether it had been a real target, and if real, whether it had been neutralized. The B-2 was at the initial point at 7:26 p.m. The bay doors open. The first GBU-57 released from the forward station. The aircraft climbed and banked. The bay doors closed. The lead aircraft was off target, and accelerating onto the egress heading before the weapon had traveled a third of its fall distance. The weapon's terminal guidance, updated by GPS in the final seconds of flight, drove it into the coastal granite above the underground harbor at 7:26 p.m. and 43 seconds. The penetration sequence proceeded through 14 meters of engineered concrete. The hardened cap that the facility's designers had poured above the harbor ceiling as the primary defense against exactly this category of weapon, and into the granite substrate. The penetration continued through the granite at a rate determined by the weapon's remaining velocity and the rock's resistance, both of which the fuzing algorithm had been given accurate numbers for. The detonation threshold was reached at a depth that placed the explosive yield at the interface between the granite ceiling and the airspace of the underground harbor. The interface was the optimal detonation point. The downward-directed overpressure entered the harbor through the fracture pattern that the detonation opened in the ceiling. Not a clean breach, but a distributed fracture network through which the pressure wave propagated into the air and water of the harbor space below. The two Type 003 carriers berthed in the harbor were at their maintenance cycle mooring configurations when the pressure wave reached them, reduced crew, systems in standby, the routine vulnerability of military hardware between operational deployments. The pressure wave that the first weapon generated was not sufficient by itself to produce structural failure in either vessel. It was sufficient to rupture the pressure-sensitive systems along both hulls, to collapse the overhead crane infrastructure that spanned the harbor ceiling, and to breach the harbor's internal flood control barriers, allowing the water table above the facility to begin entering through the ceiling fracture network at a rate that the drainage systems were not designed to manage. The harbor began flooding at a rate that the facility's designers had calculated would be prevented by the ceiling's structural integrity. The ceiling's structural integrity no longer existed in the form that calculation had assumed. The Trail B-2 arrived at the initial point 6 minutes and 14 seconds after the lead aircraft. Its mission commander had the data link confirmation of the first weapon's employment and the updated threat picture from the Growlers. The HQ-16 battery that had launched was no longer active, its fire control system having been jammed off the air after the engagement and not having reacquired. 2 additional batteries had activated in the interval between the 2 aircraft's releases, cued by the visible detonations over the water and the alert status of the sector. Both were being managed by the Growler architecture. The trail aircraft's release window was narrower than the planning had assumed. The activated batteries were constraining the available corridor, but it was open, and 6 minutes and 14 seconds was not enough time for the Chinese Air Defense Network to reconstitute its integrated picture after the Allied broadband suppression event had disrupted it. The window was degraded. It was still a window. The second GBU-57 released at 7:32 p.m. and 57 seconds. It followed the fracture channel opened by the first weapon, driven deeper by the modified fuzing solution that had been computed specifically for this 2-weapon sequential employment. The second detonation reached the harbor floor. The overpressure that it generated inside the flooded and partially collapsed harbor space was transmitted through the water. Water, unlike air, is nearly incompressible, and pressure transmitted through water propagates with an efficiency that the facility designers had not modeled in their hardening calculations, because they had not modeled the scenario in which their ceiling had already been breached and the harbor was partially flooded. Both carriers sustained catastrophic hull damage from the hydraulic shock. Both were rendered permanently inoperable at 7:33 p.m. The underground harbor facility that had been constructed over 15 years, at a cost that no public source has accurately characterized, ceased to exist as a functional military installation in the 47 seconds between the two detonations. The Trail B-2 was 310 miles into its egress when the facility's surface command post registered the complete loss of contact with the underground harbor. The Regional Air Defense Controller had by this point confirmed that 2 weapons had been employed and that both had impacted in the target area. He had not confirmed the target. He had the detonation signatures, the seismic data, from the coastal monitoring stations showing a 3.4 magnitude event consistent with underground explosive employment, and the flooding alarm that had activated on the facility's surface panel at 7:34 p.m. He had enough. He transmitted his report at 7:41 p.m. The chain of command above him would spend the next 4 hours confirming what he already knew and determining what it meant for the operational plans that the 2 carriers had been scheduled to execute in the coming deployment cycle. The operational plans would require revision. The carriers would not be executing them. The numbers that closed the package: 21 hours and 7 minutes of flight time for the lead aircraft. 2 GBU-57 massive ordnance penetrators employed in a 6-minute interval. 2 HQ-16 missiles launched by a battery commander who acted below authorization threshold. Both detonated against empty atmosphere. 1 Allied broadband suppression event lasting 47 seconds that disrupted the integrated air defense network at the critical moment of penetration. 0 B-2 aircraft lost. 0 crew from the strike package. 2 Type 003 aircraft carriers rendered permanently inoperable inside a hardened underground facility that had been designed at every level of its engineering to be beyond reach. There is a category of military capability whose strategic value is inseparable from the belief that it cannot be threatened. When that belief is removed, not by diplomacy, not by declaration, but by the physical demonstration that the protection it depends on does not provide the protection it was assumed to provide. The capability itself changes in nature. It does not become less real. It becomes less certain. And in the mathematics of deterrence, certainty is the only currency that purchases stability. The harbor is dark. The water fills the spaces where the ships were. The mountain above it remains exactly as it was. The difference is 47 seconds, and what those seconds contained.